Okay, so thanks for joining, everyone. It's about 9 a.m. Monday morning. Nice cloudy, rainy day here in San Francisco. Hopefully clearing up later, according to my weather app here. If you would, in the little chat, maybe say where everyone's from here. That would be great. So I'm in San Francisco. Where is everyone from? Always nice to kind of get a profile here. Oops, okay. All right. Okay, so quick housekeeping, and it looks like we have a nice cross-section here across the globe, which is nice. Everywhere from here, San Francisco, down to Mountain View, looks like Virginia, Dallas, New Orleans, good stuff. India, Bangalore, all right. Bengaluru in the house. So today, quick housekeeping, this talk will be recorded and posted to the following. So it's going to be YouTube, HTTPS, youtube.pipeline.ai, HTTPS, SlideShare, pipeline.ai, and the code is all at GitHub, PipelineAI/pipeline. Okay. So today we're going to do an excerpt from a regular monthly workshop that I do. If you want details on the next upcoming workshop, I think we've got one coming up in November. Let me send this link to you. There's also one, I believe, scheduled during the week, but usually we do these on Saturdays. So let me send you the next Saturday that we'll be doing this. One sec. Also, if you might have already seen this, but okay, so here's Eventbrite, right? Registration link for upcoming workshop. We've got a few tickets left. We had a sold-out event actually on Saturday, so that was really good. Had a lot of people on there, a lot of good questions, everyone learning from each other, helping each other out. Good stuff. So that one, and everyone gets their own machine. We have a TPU cluster. We don't use any local laptops. We're not installing anything. All we require is you have a modern browser and can block off part of your Saturday for this. So we try to keep it to 7 hours. We do good breaks in between. Some of you might also be familiar with the Advanced Spark TensorFlow meetup. We actually have a few of these across the globe. So sign up. The link I sent there is kind of the master source version, which is based here in San Francisco, but we do quite a bit online. So let me kick over to the slides here. Hopefully you can see these. So my name is Chris Fregley. I founded this company about 3 years ago. and to really explore the hypothesis that end-to-end pipelines are valuable and necessary and beyond just the Jupyter Notebook, basically. How do we get the model out of the Jupyter Notebook or our data products, data artifacts out of the notebook and into production? So we'll be doing just a simple, about 45-minute workshop today, and then the full workshop, of course, is on these Saturday events. So quick blurb about me. Previously at Databricks, so got a lot of deep Spark knowledge, and also Spark ML. And before that, did Netflix, was doing some machine learning for the streaming team there, and sort of data engineering, and pretty much end-to-end, like everything for Netflix streaming. I was there when we switched to Amazon Cloud, and then also when we launched globally. So pretty much accomplished all my goals for my career at that one job. And then since then, I've been doing fun stuff like Databricks and PipelineAI, and also did an O'Reilly online course called High Performance TensorFlow in Production. So that's actually still out there. You can, if you go to Safari, you can find it. Safari's a nice little O'Reilly subscription product you can go to and get access to all of the resources, including conferences. Last week was the O'Reilly AI conference. I went to some really good talks. There were a couple good SageMaker talks by Amazon, a couple good Facebook talks on PyTorch, and surprisingly, a few other companies kind of came out of the woodwork that I was very impressed with. For example, Intuit, the TurboTax people, and QuickBooks people, they had a couple talks on privacy and how to do machine learning with homomorphic encryption. So some like really good stuff coming out there. Basically, the ability to train on encrypted data without ever having to unencrypt or decrypt. And there's certain properties of a homomorphic encryption algorithm that you can perform multiplication, perform addition on the encrypted values, and get an encrypted value that represents, when it's decrypted, will actually represent the true value. So pretty interesting stuff. They for division and other more complicated operations, mathematical operations, they do have to perform a little bit of like estimation and kind of fuzzy math there. So pretty good talk. So check that out. And then also this meetup here, which I sent a link. So if you don't mind, I think we're up to about 12,000 people. The San Francisco one, this one's been around for 4 years, and there's thousands of slides and hundreds of videos out on the meetup site for this stuff. So once again, the next workshop is November 2nd. Sign up for this if you are so inclined. Okay, and I'm assuming most of us are okay with command line. We'll be doing a little bit of command line today, probably more than the rest of the overall workshop, mainly because of the state that things are in with KubeFlow. So kind of, we'll be doing a little bit of Python. I'm going to show you guys some Python code. You don't really need to know linear algebra for today. Today will be more on online predictions and productionizing models after they've been trained. So other workshops or rather webinars that we've done have focused more on the training. Today we're actually focusing more on the predictions. So hopefully you're okay with Docker. I'm going to show a Docker file here in a bit too. You don't really have to know too much about Docker. Well, in theory, for KubeFlow, you actually do need to know a little bit more about Docker than you would like. But things are getting better. And hopefully you're okay with Jupyter Notebooks. They're pretty commonplace these days. Quick poll as of July 2019. We actually just did a poll on Saturday as well too, so I still have to gather those those responses and then merge in with these responses. But this is a KubeFlow webinar pretty much, and so there's a lot of people interested in that. Surprisingly, not too much GPU interest and not much PyTorch interest. Like keep in mind, this is a relatively small audience, right? A few hundred people. So this is certainly not representative. And also this workshop is biased towards TensorFlow because we do cover TFX, which is the number 2. We're not going to get too much into TFX today. We do go into it in gory details during the workshop. So the full workshop. Also, a little bit of interest in Airflow. Starting to see more interest in ML flow, which I actually covered in the last webinar last month on the Monday. Also, this audience didn't seem too interested in Spark stuff. Again, Spark is almost like ubiquitous now, so probably people aren't coming to this workshop for Spark stuff. So, and then obviously TensorFlow Keras. Clear leader here, Amazon Web Services and the infrastructure. We do see, so what was interesting is in the real world, I actually see quite a bit. I see Azure and Google Cloud flip-flopped from what's represented here. So yeah, we always see Amazon as the clear winner. Next up is Azure, and then next up is Google Cloud, which is usually way down to about 2 or 3%. Today, or sorry, for this particular poll, we were actually running it on Google Cloud. KubeFlow is also associated with Google Cloud, just by nature of its examples. And affiliation kind of stemmed out of the 2 Google projects, both Kubernetes and TensorFlow. We see almost no DigitalOcean. I don't actually know anyone that uses DigitalOcean. I'm sure that there's hundreds, millions of people using it. I just don't know any of them. And still quite a bit on premise. So the other thing here with this workshop and this particular audience was these are people who have existing infrastructures, can't use the cloud services for whatever reason, or don't want to use the cloud services like SageMaker or Google Cloud ML, and they need to get something that works across all of these. And that's really where PipelineAI comes in, is hybrid cloud, multi-cloud, all this kind of unified pipeline. On the right is what people were most interested in. So today we're actually covering that highest one there, the 68% deploying models and services in production. Reproducible experiments came in a little bit lower than I thought. This is, using tools like Pachyderm and DCV and things to actually be able to go back and in a point in time reproduce an experiment down to the, single or the actual data set that was used as a snapshot in time. So it's kind of the holy grail, the reproducible experiments, but it's one of those really, it seems to be only the top 5% of the hardcore machine learning shops need this solved. This is our sort of observation. And yes, anything beyond that, people, or those top 5% typically have built their own mechanism. Okay, so a couple questions coming in from the chat. If you guys wouldn't mind also change this to all panelists and attendees so everyone can see the question. I'll post it here. O'Reilly conference, Intuit gave the talk on homomorphic encryption. There's also a project on GitHub by Microsoft called Seal that is used by the Intuit folks. Okay, so yeah, the homomorphic stuff was really cool. It's really still in its early days. The estimated time to train is about 50 times longer because of the compute intensive portion that is introduced by the homomorphic encryption. But the idea here is we start making little advances, and then at some point we can get that down to about 3 times or maybe 2 times the training time, and then at which point it's certainly worth it to keep everything encrypted. Okay, and AB and multi-arm bandit tests, so we'll do a bit of that today. That's 52% on this poll here. Feature engineering seemed to come in around 40%, so that's good to see. People are still thinking about feature engineering and not just throwing raw data into these models and keeping their fingers crossed. Feature sharing across multiple teams. What I was trying to get here is, is there this need for a feature store is kind of the overarching concept here. So feature sharing, meaning there would be one kind of data warehouse, if you will, or feature warehouse of pre-materialized features, and people and teams within an enterprise can share. So this actually came in quite a bit lower, possibly because it's not well understood, or one of those like rare cases, or sort of relatively rare cases where you don't know what you don't know yet, right? So I think once people see these feature stores in action, people will wonder how they ever were able to like operate without a feature store. So think of, if you're familiar with databases and sort of materialized views, think of it like materialized inputs to your machine learning. And when you talk to other groups in the lunchroom or at the water cooler, you hear about features that they're using in their machine learning models, and you say, oh wait, I actually might want to try that feature in my machine learning model for my use case. Chances are, if the enterprise is all sharing the same data sets, which they usually are, users and user activity on the website, mobile activity, they can share these features across. So having some nice tooling around there seems to be a hot spot here in the Bay Area. There's 3 or 4 startups I can think of that are focusing on this, and potentially the cloud providers might actually start providing this as well too, because it is a bit of an infrastructure type thing at the end of the day. Data ingestion still 25, 26%. I thought that would actually be a little bit higher, but because you have to get data in, maybe people take it for granted these days that the data has to get ingested. The other things coming up here, about 40%, batch predictions, online training. I actually thought that would be a lot higher. I think that's a case where most machine learning use cases today are batch oriented, and it's good enough to run like an overnight job and build all the predictions, then push them online through a SQL database or Mongo database or a Cassandra database. Ad hoc data. So this is the ability to actually analyze data within a Jupyter notebook, or sort of analyze your model or data sets, and kind of ad hoc build different models. Maybe try Spark ML, maybe try TensorFlow, try XGBoost, and see what happens. So that's really notebook type stuff. Oh yeah, one kind of fun little anecdote here is, so we're speaking with some VCs recently. This pops up every now and then when we're doing the fundraising, and we're starting to approach 4,000 stars. We heard from one very, very prominent VC that if you can get to 4,000 stars and show rapid growth to this 4,000, this is roughly worth about $6 million in seed funding. And it should make some of us laugh. It's kind of the current state of affairs. I think if I give this talk in a year or two, this might either go down to 1 million, or could maybe even bump up to 12 million. But the idea here is sort of very, very coarse-grained like calculation, but every star is worth about $1,500 to these VCs and seed funding. So yeah, obviously you need good fundamentals, you need a good team. I'm not going to share who this VC is because it's completely ridiculous, but this is the current state of things in the Bay Area, so just kind of funny. Okay, we're going to be using Community Edition today. I think I'm going to skip through some of these. Oh, you might see some, actually today you shouldn't see too many errors, so I think we'll be okay. This is from the regular workshop here, so some of these don't make sense in this context. And let me cover this real quick, just to set more context. So, why TFX, why KubeFlow? Well, really there's, 5 or 6 different systems at play here. System 6 is kind of a cross-cutting system, that represents logging, monitoring, configuration. This could be maybe the feature store thing I was talking about before. System 1 is really data ingest and data transformations. This is your load and your transform. This is the T and the L, for the L and the T from ETL. System 2 is data splitting and sort of ad hoc training. I mentioned ad hoc before, sort of splitting data into training data and validation data, or training test and validation data, depending on if you're doing hyperparameter tuning or not. Let's see, building the model, validating the model. The reason these are different systems is you could do these with different sets of hardware. So I could actually do some of the ingestion and data analysis and transformations on my laptop or on a dev server or somewhere sort of offline. System 2 is where I'm probably using Jupyter notebooks, and I'm doing matplotlib visualizations or Seaborn visualizations. System 3, I might need a beefier machine. Maybe I need a GPU for this, a single GPU, just to train the sampled or the smaller ad hoc training and validating. Once I figure out which model, which framework I'm going to use, XGBoost or TensorFlow or whatever, I have to pick some hyperparameters. So hyperparameters are ways to alter how the framework is going to learn the model. So depending on which algorithm that you use, if you're using decision trees, you might want to change the depth of the tree. And the deeper you go, the longer the training run. So if I'm doing a 500 layer deep decision tree, that's going to take, potentially 500 times as long to train. Not really, but I'm just kind of exaggerating a bit here. If I do a 5-layer deep, that's going to train much faster than a 500-layer deep. Okay. Hang on a second here. Let me reduce some of these notifications. Okay. Yep. One sec. Notifications, do not disturb. Okay. And so if I'm using something like a deep neural network, some of my hyperparameters are going to be how deep is my network? Is this, 500 layers deep? Is this, 5-layer shallow network kind of thing? And once I decide that sort of in a smaller, and from System 2 and System 3, then I can unleash the full distributed training at scale, System 4. And this is almost always, large dedicated clusters, oftentimes GPUs. I could probably get away maybe on System 3 with just doing a CPU. Maybe it'll run a little bit longer, but when I actually unleash all of the data and do, I want to train in parallel, oftentimes I'm going to do this with many servers. So in Spark land, for example, this would be I would train locally on my laptop in System 3 or a small dev cluster in System 3, and System 4 is when I unleash the full 10 terabyte cluster. System 5 is really where we're going to be focusing on today. So, rolling out these models, packaging them up as Docker images, deploying them to the Kubernetes cluster, doing an A/B test where we could shift traffic between different versions of the model. So hopefully the samples I provided today will be able to cover System 5 in pretty good depth. So, quick plug again for the workshop. We actually cover all of this stuff. We cover TFX. We do pipelines with Airflow and KubeFlow. We do hyperparameter tuning with KubeFlow and actually MLflow, which I'll cover here on the next slide. And then we can deploy notebooks with Kubernetes. So I could actually take an ad hoc notebook that I've created and deploy this to Kubernetes as a long-running job, like a batch job. So, very similar to other technologies where you could just right-click on the notebook and say run on the cluster. The extras that we do in the full workshop are TPUs. We cover MLflow pretty extensively. I'm probably going to move MLflow into the core and not make it a bonus extra because I actually do like the project quite a bit. It's an experiment tracking. That's the project that we covered last month, and I think the video should be out there. TensorFlow privacy, I'm probably going to add the homomorphic stuff here once I understand it. TensorFlow 2.0 is, we cover extensively today. We're just really going to be using Python today, and I think a little bit of scikit-learn, because today's focus is really A/B tests and that kind of area. Okay, so now that we covered the basics, I think we have time to do, let me see here, get you guys a link. So take this link. Oops. Okay. Let me paste in this link. Grab yourself. So someone's asking which of these systems 1 through 6, the full workshop covers all systems, 1 through 6. Distinction between TFX and KubeFlow. Let's talk about TFX versus KubeFlow. I'll answer this question very high level, but we get way into it during the actual workshop. TFX is really a set of libraries, and KubeFlow is a way to coordinate those libraries. So KubeFlow and Airflow, so let me step back. KubeFlow is a very, very large package or set or bundle of open source projects. KubeFlow Pipelines is similar to Airflow. KubeFlow also has Jupyter Notebooks, which would be similar to like Jupyter Hub, or it actually uses Jupyter Hub beneath the covers. And TFX really is Google's kind of longer term strategy for TensorFlow. So so like TFX, I think I have one little slide here on this, and then I want to get back to the workshop or to this particular webinar. Let's see here. Okay, so Airflow pipelines. I think we're all familiar with Airflow. You can actually use TFX with Airflow, and in fact, you see this one-to-one mapping here. So TensorFlow Extended really is the full end-to-end. So feature loading, feature analyzing, feature transformations, training the models, validating the models, deploying the models. TFX has libraries to do all of this. And if you see in the upper left, there's Airflow runtime, there's KubeFlow runtime. If you look in the upper right diagram, the upper left of the upper right diagram, you see tabs, Airflow runtime, KubeFlow runtime. These things, so what this is saying is you can use TFX with both Airflow and KubeFlow, and this in the workshop we cover all of it. So, but just know that TFX really has been kind of slowly creeping out. TFX is used internally by Google for pretty much everything. It's a standard way for them to validate the data that comes in, generate some statistics on the data that comes in, perform some transformations with the knowledge that they gain from the statistics of the full data set by looking at all of it, and training the model, and then validating the model on different slices of data to make sure that there's not that biases have been smoothed out and we have enough data from different samples of different classes of the data, and then we can actually push the model into production. KubeFlow, you can use TFX as well, and there's some examples there. So let's cover that at a later date. Let's see, what's this? Okay, yeah, someone posted the link to O'Reilly. It'll be in a couple weeks. Okay, so yeah, they'll be posting it in a couple weeks. I'm not sure if Intuit actually has a blog post or anything on this, but so here's the link. Go to this link and copy, paste the URL into your browser. So that should generate an HTTPS:// it'll be community edition. So I've given everyone a place to go in their community edition. I am student 00, so I'll be using that. Kill these. So let me know if you have any problems getting to that link because of a firewall or a port issue or VPN issue. Let me know and I'll send you the link directly. So get in there and click on the 18 one. And when you do that, it should generate, you'll see a student _00. So so just keep in mind, mine is student 00. You guys will be some other number. And keep that number in mind. So the context here is this. We're going to deploy a simple Python-based model, I'll put that in quotes, onto our Kubernetes cluster as onto our Kubernetes cluster as a microservice. And once we do that, once the microservice starts up, we'll call the service with a REST, call the services REST endpoint with some data and get a prediction. I'll then show you how to build your own microservice similar to the one that we're deploying today. Next, lastly, we'll deploy 2 microservices in an A/B, or 2 different versions of the model in an A/B test scenario. So each as a separate microservice A/B test. Okay, so anyone else that can't open the link? Let me see. Okay. Okay, Michael, I'm getting you the link. Okay. Okay, Alberto, let me get you the link. Or, yeah, Albert. Okay, there we go. Okay, Roman, do you need the link? Let me send you the link. Get one more going here. Okay, Deepak, sending you the link. Okay, for those of you that can't open, even though I've given you the link, you have some other firewall or VPN issues going on. So unfortunately, I don't have time to debug those with you now, but try to come back to the community edition later and see if you can debug it. Obviously, open up your developer tools and see if there's any failed. Community, so we're using Jupyter, and Jupyter opens up some WebSockets beneath the covers and things. So if you have very restrictive firewall rules, which some of you might be at work already, that's going to get in the way. So anyway, just watch us here today and enjoy it, and hopefully you can see. Okay. So, oh, there's two Michael Sims. Okay. So. Okay. All right, so I'm going to continue on here. I'm going to use my 00. So I'm 00. You guys use your own. The very first thing, let me zoom in here. Okay, hopefully. Okay, John's good. Yeah, so John, you'll need to do, yeah, John, make sure that you go to this one here. Looks like the link that you provided is not, I don't think is the right link. So go to that specific link there, John. Okay, let's get started here. So let's go to the simple, so click on the simple serving REST. Don't worry about deployments, that will actually be opening up those files here within the parent notebook. Okay, so open up 18 simple serving rest.ipynb. Crack that open. You must change student ID equal to student ID equal your 2-digit number. Make sure that you put quotes around the 2 digits student number. Okay, so for me, it's going to be 00 in quotes. And what we're doing here is we're kind of shimming this a little bit. Like normally when I do the workshop, I give everyone their own instance. That was going to take a little bit too long for today's 1 hour thing. So we're all sharing the same instance. So we have to kind of hack a little bit. But I've already done I've set up the code for the hack. So as long as you get this right, so don't use 00, use your 2-digit student number. Has to be the 2 digits. Now that that's run, we can cat this, and you should see the 2-digit number here. And if you want to take a look at this, but let's keep going, and let's actually just run kubectl create. So we're using a Kubernetes cluster beneath the covers. We created this deployment. Okay, so yeah, looks like a bunch of people have already started this, so that's good. Bunch of things are starting up, a lot of different models out here, awesome. And you could kind of find yours if you do a browser search for 00. Hopefully it'll, yeah, mine's starting up right here. And if we take a look, so that's going to take a second to start up. Now down here, the next step, make sure that you change this student ID. Next, make sure you change student ID to your 2-digit student number. Okay, so Lucas, if you're having problems, just pick another number after, or here. Let's say 82. So Lucas, try this one, use that one. And and then, yeah, so you could try different numbers. If someone wants to start at 99 and work back, that's okay. I'm probably going to enter a disaster mode here, but okay. So change this to your 2-digit student ID, mine's 00, and run this, and we should actually get a nice clean prediction back. So here we've passed data in, and I'm going to show you guys the model here in a sec. So just know that we've deployed a model onto the Kubernetes cluster. We could see the Kubernetes resource right here. And these are all running inside of this namespace called deployment. So it looks like a couple of people jumped ahead and did the A/B test one, but for now, just take a look at this. So let me run this again and make sure that my model started up okay. It did. So this means 3 of 3. So the 3 of 3 means 3 pods, or sorry, 3 containers inside of this single pod. So Kubernetes has a model of containers that are Docker containers that we're all familiar with, and pods contain one to many containers. The reason that there's 3 containers here is that the KubeFlow framework has injected things in here. We're using Istio as the main routing mechanism. Istio injects a container in to do some of the advanced like A/B testing, which we'll do here in a minute. But like just know that the KubeFlow and the Istio framework that we injected here. Now, this YAML was actually hand generated. There is tooling to generate this YAML that's in the works. And some of it could be proprietary, some of it might be open sourced. But at the end of the day, whenever you crack open any Kubernetes YAML, the first thing to look for is what is the Docker image that's being used. And I'll show you guys how to actually build and change the Docker image next. But just know that this is a custom pipeline Docker image. It's very, very simple. It's just slurping in the Okay, hopefully you guys can hear me okay. Been having some problems. I installed the iOS beta we're preparing for. We are working on a mobile app for one of our customers and using Pipeline on the back end. And I've been testing out the mobile app. And iOS 13 has been really giving me problems here. So, okay, back to audio. So what we'll see here is, very simple. This is telling us which classifier was being used. This happens to match directly to the Docker image to make it nice and clear. This is the response. And if you're familiar with scikit-learn, this is a probability, proba. Let's crack this open though. So I think the next step here is let's actually look at what went into this Docker image. So I first want to show you guys how to deploy things. And I know that there's some magic going on here. Just know, just like any developer or scientist or engineer, we're going to take somebody else's working example and make the changes that are necessary. So one of the very first changes that you'll want to do is put in your own .py file here. So this is literally the exact same directory that is being slurped into the Docker image and served by this particular, or being placed onto our shared Kubernetes cluster here. So this is a very, very simple model. You can, if you're interested, go in and look at the details. Just know that every model that participates in this serving framework has to include this predict method. And it has to be wrapped in a class that's named exactly the same as the .py file. This is a convention, right? This is just how KubeFlow is doing this convention for model serving. You can, as long as you name this class the same thing and have this predict function, you could do whatever you want in here. You could load up a TensorFlow model. You could load up a Keras model. You could join it with a database. You can, when the features come in, you could do some advanced feature engineering and normalization, and then join it with some SQL data and do whatever you want. Just know that every line of code that you add here is going to increase the latency of the response. So this is quite a bit of freedom, but also with that comes a bit of responsibility to make sure that you're not going to take down the system or overload your SQL database, whatever you're joining with. Okay, and anytime you see a Python function, the next question should be, where am I defining my requirements? So this particular framework, this particular KubeFlow library expects that you have something called requirements.txt. In here we see NumPy, we see the project that's actually powering this within KubeFlow called Selden, and then we're going to, and then here's the actual Docker file that ties all this together. So if we were to build this Docker image, which you can't actually build a Docker image inside of this notebook just yet, we're trying to figure out a safe way to do it. We would have to have opened up or installed Docker in Docker, because keep in mind, this notebook is actually running as a Docker container inside of a pod inside of our Kubernetes cluster. But and so there's certain permissions that we don't want to give too much freedom. This is community edition. I want you guys to be able to play around, but I don't want you to install your Bitcoin mining Docker images and start launching them on the Kubernetes cluster. So just know that you would have previously built and used this Docker file to build the Docker image. Here we're specifying the model name. Again, this has to match the .py file name and the class defined in there. And you can change this from REST to gRPC. You can, by convention, this is listing on port 5000. I wouldn't stray too far from this template. If you do start straying far from this, you could get yourself into trouble. Okay, so I think hopefully you have a better understanding of what goes in here. And that's literally, like I said before, that's when you crack open the YAML, that ends up being this Docker image right here. And other things here are we're giving it like an internal name, giving it this predictor ID is literally used in the REST call. So up here, the predictor ID is mean-classifier, and for me it's -00 because we're running multi-tenant here, and that means mean classifier 00 over here. I could call into somebody else's. Let's assume, well, let's find somebody else's. Or someone did 6 instead of 06. So let me change it. I should get their prediction back. Okay, it's all the same model, so it's likely going to give the exact same prediction. But okay, so let's switch over to the A/B test. And this is using the exact same Docker image. It's just giving it a little bit more, let's see, so I'm 00. I'm going to put quotes around that. There's more configuration to define it as an A/B test and to tell it how much traffic should go to A and B. Okay, so I'm going to modify my student file. I'm going to cat it to make sure. This says A/B test model 00. Again, this will literally be used. So deployment ID, this will literally be used as the in the REST API. Okay, so A/B-test-model. We'll see down here, we've got V1 and V2. Let's find it here. So this is model version 1, or sorry, model version 2. And okay, so right, this is called classifier 1. And this is called, and this uses the exact same Docker image. Or sorry, this is classifier 2, and there should be a classifier -1 up here, which there is up here. Okay, but these are both the exact same Docker image. Yeah, so classifier 1, and then there's another section. So there's actually two containers here, classifier 1, classifier 2, and they're being routed by KubeFlow itself in conjunction with Istio as the actual routing mechanism, which is the lower level infrastructure. Okay, and just know, you can, so here we're saying use the REST API within classifier 1, use the REST version of classifier 2, you can mix and match. It's saying just do random for right now and give it as a 0.5 for the ratio. So do half and half. You could change this to, there's more advanced ones. I didn't get a chance to get the multi-arm bandit stuff working, but you can use multi-arm bandit type of strategies here, which will slowly shift traffic to the winning model based on feedback that's being introduced back into the system. So there's a particular reward in the multi-arm bandit scenario where you yourself define that reward. And if one model tends to get rewarded more for whatever goal or the objective that you're trying to achieve, then more and more traffic will get shifted over. So today, this is just random, splitting 50-50. You can pin it to a customer ID. So, all customer IDs between 0 and, 500,000 get version A. People with particular user IDs, you could slice and dice this as finely grained as you want. Something we did at Netflix oftentimes, if we were trying to isolate one particular device that was having problems, like the Xbox or PS3, we could actually shift traffic to kind of a staging production environment, or I'd say like a very isolated production environment that was still production and still writing to the production database, but we could add in quite a bit of logging to identify specific and not affect the whole rest of the system. So very, very advanced routing capabilities that are really given to us by Istio, but are made human grokkable and application level by the KubeFlow framework here. Okay, so let's actually create that. Looks like a couple people have already done it, and look at the deployment here. So it looks like a bunch of us ran it already. You see 0, 0. So some of these are still pending. We could potentially be in a scenario where we've run out of resources. Let me do one thing to keep this moving along. I'm gonna do kubectl. So I'm actually on my on this community edition. You guys won't be able to do this. I'm going to clean up all of these deployments and delete namespace deployments. Okay, and now that these are clean, we should have free resources. Have a lot more people on today than I thought we were going to have. So let's wait till these settle down and then go back and rerun the create. And then you should be able to, yeah, because it looks like only a handful of these actually came up. So I apologize if yours already came up. And hopefully you were able to test it, but I'm killing all these now, and then we'll just do the A/B test stuff. Still. Okay, these should all be gone now. Okay, a bunch of these are terminating. These will slowly terminate, and then do the create here, and it's creating 0. So once the cluster settles down a bit, you can recreate that A/B test model, and then the A/B test one takes a little bit because it's actually spinning up 2 containers and then a router for those containers. Okay, and then make sure that you change the student ID to be what your student ID is, and we'll wait for this to settle down. So if you see this kind of error, it just means that the containers haven't started yet. You can go up here and do this get pod and see. So mine 0, 0 is still coming up here. Okay. Pod is initializing, that's good. A couple of us are still hanging in there. Which metric are we testing in here? Okay, question is, which metric are we testing? So I'm gonna answer the question I think you're asking, which is, well, actually, yeah, I don't quite understand the question. So let me put that back in here. Can you clarify at Alireza? So all that we're doing here is just making a call to the model and getting back to prediction. I think if you're talking about the multi-arm bandit scenario, yeah, the KPI here really for like today's session is just getting connectivity. I think the next workshop or the next webinar that we do, because we're running out of time, we'll actually take a look at the Grafana metrics. And there's this project in KubeFlow called Kiali, which we're not going to have time to cover today. So let me see if I can get to it. It's working. Oh yeah, this is working. Okay. I don't remember the password though. Okay, so this is on Community Edition. If you notice, okay, and this is actually looking at, let's see. So there's this project within KubeFlow called like Kiali, and we can see all of our models here, and obviously look at the health. That's the obvious one, but we could also, I think if I click workloads here, we could take a look at the inbound metrics, outbound metrics, the health of the service. Pod has no version label. Okay, that's a soft one. We see some of the Istio stuff here. We see all the containers. Let's look at inbound metrics. So this is for each service. We could see traffic coming in, and let's see here if I have. And make a call here and try to generate some traffic. Kiali, so we run this a couple times. I'm getting some values back. One thing to note, you'll see actually in the response which version. So here, classifier 2 received this, and it should be a 50-50. So I should see, on average, maybe it'll take a few. There might be some runs. Where possible, Istio kind of chooses the most responsive one. So here we got classifier 1. But if we specified 50-50, it should be pretty much 50-50, 1 and 2 over the long run. It looks like 2 is getting a lot more here. So let me go back to Kiali, and I'll cover this much more in a future one. But let's see, can I actually see this in Grafana? No, I didn't think that was going to work. Okay. Let me take a look here. Okay, this one. Oops. Okay, services, boom. So here we could start seeing some of these metrics. So, really, you can look at the 99th percentile, 99.9 percentile. You could do these at different intervals. You'll notice some overlap here with Prometheus. This is just kind of it's a slightly better, in my opinion, kind of unified view. So here I can look at all the services and how they relate. It's got tracing kind of implicitly included here. Could see how these services interact with each other. And then also get kind of a high-level glimpse of the HTTP success, and could do last minute every 15 seconds. So yeah, pretty cool stuff here. We'll cover that much later, or in much more detail later. So I think we're at the top of the hour. Have to cut it here. Kiali can use for other services. Yes, Kiali can be used for other services. One trick with Kiali, and this actually took me forever to figure out, was you have to explicitly allow other namespaces. So I've had to go in and actually hack the Kiali configuration to show deployment namespace. Yeah, otherwise it's pretty conservative as to which namespaces it's going to show, and rightfully so. So if I just show all the KubeFlow stuff, this will be everything. This will be all the Jupyter stuff. This will be TensorBoard, all the other things that are involved. So yeah, once again, this will be topic of the next webinar, or if you come to the workshop, we'll cover it much more detail. It's not more towards KubeFlow, right? Which is correct. Kiali can scrape any namespace that you ask it to scrape. By default, it's very conservative. Will likely not scrape your custom namespaces. For the next, yeah, so just go, Google for Kiali, Istio. How did we get set up with that? Istio.io, and I think Istio. If you Google Istio and Kiali, I think there's a pretty good guide on how to get it to work here. So just follow these instructions. Yeah, KF serving, I'm definitely keeping a very close eye on. Pipeline's roots are in model serving. We've extended into model training and distributed training and hyperparameter tuning out of sort of the asks from our customers, which are, love the fact that we can deploy models, but they haven't yet even trained any models. So we've been working with them more on the training side. At the same time, KubeFlow popped up. At the same time, Seldom popped up, and we're totally adopting those standards. It's a lot of work that Pipeline doesn't have to do, and these are all very good standards to build upon. So, yeah, KF serving. I tune in about maybe once or twice a month into the working group on that. Seems like it's going pretty well. I haven't had very good luck getting it to work, so I'm just sticking with what's working for right now. The whole point of the PipelineAI KubeFlow distribution is stability for our customers. And so when we see these projects do start to mature, we then pull them in as needed and make the necessary changes. So, okay, thanks everyone. Looks like people are hopping off here because people have to get to meetings and stuff, I'm sure. So thank you much. Thanks a lot. And see you at an upcoming workshop, webinar, meetup, or conference. Come say hi. Talk soon. I'll post this right after. See ya.